Hello everyone, we are Team Smart Stack, Team Aditya and Harish. We have finished our first year in mechanical engineering at IIT Madras and we have a passion for AI. We welcome you to the demo session for our project submission to the Appian AIgnite Hackathon 2025 and we are very happy that we got to participate in the round 2 of the same. This is the architecture that we have implemented in our project solution. All the source code and other such documents are stored on the local first and pushed to a GitHub repository. From there, the code and scripts are uploaded to cloud native storage, product catalog, other such details to a Google Cloud bucket, and the GCS RAG bucket, it is the knowledge base, stores user manuals, PDFs, and other such uh, documents and images. From the cloud native storage, all scripts are sent to the Google Cloud App Engine, and this is where it gets interesting. The user interacts with the front end by sending text or image queries or both, which is then passed along with the data from the GCP MySQL database and the RAG bucket to Vertex AI as context, from where the response is returned back to the front end and the user can view that and act on the same. These are the project files we have submitted as part of our submission. Smart Stack Blueprint is the current PPT file. We also have a demo file and the source code on our GitHub repository. The main tech stack that we've used in our project includes Google Cloud, which we have opted as our hosting platform. The backend is done in Node.js framework with TypeScript and Express, and the front end is in React framework with HTML and CSS. We've used the Gemini 2.0 Flash model for all API interactions. These are the artifacts that are the files that we'll be using. This is app.tsx, which is the front end on which the user will interact with our application. We have displayed all the products with their images and prices by retrieving the data from the database. Package.json is where we have all our dependencies and the user can run npm run build in case they wish to deploy on any fresh device. And querydb.tsx is where we're retrieving data from the database. This is the GitHub on which we have uploaded all our files. Smart Stack Store stores the front end part. Smart Stack Store dash backend is where we have all our backend code along with the app.js, which is created after TSC. Smart Stack Store here is where we have more of our logic along with some other code that's used on the platform. Smart Store is where we have the code that interacts with our um, Gemini API index.ts. Let's take a quick look at the Google Cloud Platform. We have created a database instance and a table product underscore catalog where we're storing our product catalog in structured data format. We also have a bucket in which we are storing all our images, PDFs, user manuals, and other files. This is the front end we have built for our Smart Stack Store as part of the storefront. Here, users can view different categories of products. The price, brand, and other such information are retrieved from the Google Cloud database, while the images for the products are retrieved from the Google Cloud bucket. And the users can pick products as they wish. And we also have an AI assistant that can help them pick products and uh, ask other queries based on the various documents. As you can see, most of the files and services have been already hosted on Google Cloud Platform, but some of the code has been run on localhost, and we are learning how to deploy the same as an app. This is the front end where we're going to see the Gemini API calls in action. To make this a possibility, I've enabled the Vertex AI API on the Google Cloud Platform. And for authentication of credentials, I've created a JSON key file for the default compute service account. This is the code that implements the uh, various API calls. I have set the environment variables in an env file. There's the MySQL connection set up and the call to get the data from the cloud MySQL. We are then integrating the data from the cloud MySQL and the Google Cloud bucket as a single context variable, and then that along with our user prompt we're giving to the Gemini API. Now let's see the code in action. I have started the Google Cloud proxy on my local and the server has been started for the app. through npm, that is Node.js. Now let's see the backend in action. We are going to give a prompt, suggest a good TV, and we're going to see how our shopping assistant uh, helps the user in this aspect. We have two API calls in our network. One is the pre-flight, and then we have the actual fetch. The Gemini RAG query gets data from both SQL and buckets and then passes that as context to our Gemini API. Now the response returned by the Gemini API is about a product that's there in our product catalog, the 4K LED TV. Let's consider another case where the user wishes to upload an image along with their text prompt. Now here we can notice that our image is also being uploaded. The pre-flight API call has passed, and in our fetch we have the payload as our image in base64 format along with the text prompt. This will be sent with our context from both SQL and the buckets to the Gemini API call. While the API is in processing, these are the various API calls that have been uh, that have taken place while I was testing and running the project during the course of this hackathon. Here we have the various API calls for the Vertex AI API, and this is where I go to check the various logs to see if the API calls have passed correctly or not. Now the API call here has passed, and we notice that it retrieves noise cancelling headphones from our Google Cloud SQL. The response is the same as well. We can see that in our network analysis. Let's take a look at another case. Suppose the user wishes to ask about the specifications of a product, the details of which we have not mentioned in our Google Cloud SQL. Now, this is a user manual that I've downloaded from the Bose website, which is one of the products in our product catalog. And on the 15th page, it says that we need to download the Bose Connect app in order to connect our headset. This is another manual that I've downloaded from the Sony website for a different headset in our product catalog. And here it says that the headset complies with IMDA standards DB00353. Now the user has asked about both of these to the Gemini API, that is our AI assistant on the shopping platform, and we can see that for the connection to the Bose headset, it says that we need to download the Bose Connect app. Now both these PDFs are stored as unstructured data in our Google Cloud bucket, and for the IMDA standards, it says that the wireless stereo headset complies with IMDA standards DB00353. So now we can see that our Gemini API is able to read context even from structured data, unstructured data, as well as the images uploaded by the user. This brings us to the end of our demo session. Thank you once again for giving us the opportunity to take part in this hackathon.